Hey everybody, this is Jacob Tucker here, and welcome back to another Flow video. In this video, I'm actually going to be showing you something that we recently released at Emerald City called CryptoKitties Arcade. Now, this is a really fun new educational platform that is totally inspired by CryptoZombies, which is like basically the most popular way to learn Solidity. It's like a play-to-learn platform in the Ethereum world where you can create zombies and make a factory of zombies and have them fight each other. And the whole time you're kind of learning Solidity. That's what we brought to Flow, or more specifically Cadence, to help you learn Cadence, where you're going to have fun with CryptoKitties, which is a super popular, project that was created a couple years ago, actually by the Flow team themselves. If you didn't know that, it's some cool history. But we're going to be using CryptoKitties today to help you learn Cadence and have a really fun time learning Cadence. So you can actually visit this website at arcade.ecdao.org. I'll leave it in the description. And the platform itself is a really self-explanatory game. But I figured, why not just make a video, walk through it with all of you, in case you have any questions and just want some extra insight on the platform, or maybe even some of the concepts that you go over in the lesson. So let's just dive right into it. Now, before we do that, I will note there is some cool music that you can listen to while you do this if you click the music button. But I'm gonna leave it off just because I don't want that playing while I'm trying to talk to all of you. So we're gonna click play now. And we are in the first mission. Now, right now, because the platform is so new, it actually only has one chapter. The chapter has 16 lessons, so it is a bit extensive, and it's a really good beginner overview. But don't worry, there will be more chapters as we go on, and I'll make a video about that when it comes. But essentially, what we're going to be doing is coding this. So it's pretty simple. Just something where you can type in any name you want, like I'll type in my name, and it auto-generates a random kitty based on the name that you put in. So it'll always be deterministic. Like if I type in Jacob... Oh, I guess not, actually. Look at that. That's kind of cool, actually. So it is truly random. That's actually better than I thought. So it is truly random. So yeah, you can type in any name. It'll just randomly generate something based on the characters of your name, plus some extra randomness, whatever. But really, the point of this is to help you get an introduction to Cadence. So let's just dive right into it together. So... and actually, I just realized that this is probably, I actually should probably clear my browser storage because I've actually done this before, and one really cool thing about this platform is that it automatically tracks all your progress. So I'm actually just going to delete all that. That way we can refresh the page and just start new. So here we go. Okay, cool. So you will see this when it appears. So the first lesson is obviously just about smart contracts. How do we actually make a smart contract? Well, it's pretty simple. You can see right here, here's an example, and each of these lessons will give you an example of, what you're supposed to be doing. And actually, let me make my webcam a bit smaller too, so that you can see kind of the buttons here. I'm actually gonna put you on the left-hand side so you can see these buttons. Okay. So yeah, let's just do this. So we see an example here, and I'll do that right now. So it's telling us we want to make a contract called Kitty Creator. So the way you do that is you say access all contract, and then we put the name Kitty Creator, and we open up some brackets. And we're also going to add an init function all this does, this init function, is this function will run when the contract is deployed. So pretty straightforward. And if we submit our answer, boom, we pass. That's awesome. We'll go to the next lesson. All right, so now that we have created our contract, let's actually add a variable to this contract, right? We want to store some state. I'm going to make this a bit bigger so you can see it too. Hopefully that's better. Okay, so we want to add some state, right? So you can see in this example that they added a my integer to the contract. And so we want to add instead a total kitties variable. So let's go ahead and do that. So the way you do that is you say access all, let total kitties. And we're going to give it a uint64 type. It's essentially an integer that ranges from 0 to this number right here. So it's actually included in the lesson. So we could put int here we could put int here that would represent sort of any integer, negative, positive, whatever. But I actually like using this type more in Cadence. And in order to initialize this, you'll see if we try to submit the answer here, it's going to say it's wrong. It's because in Cadence, you have to actually initialize your variables to a default value, and we do that in the init function. So again, when the contract is deployed, which means when the contract is put on the blockchain for the first time, init will run only once. This will only be run when the contract is deployed. And if we submit our answer, boom, that is correct. So that's awesome. Okay, so this next one is, what about a function, right? We just added some state to our contract. What if we want to add a function to our contract? So Once again, we can see there is an example, eat burgers right here, that takes in a name and an amount. I guess a certain someone is eating an amount of burgers. I don't really know. And then you can see an example of it being called here too. But let's just go ahead and make our own function. So it wants us to create a function called createKitty that takes in a name and a DNA. Let's do that. So we do that by saying access all, function, createKitty, name, string, DNA, uint64. And we're going to make it an empty function just like that. So this should work. And boom, it does. So our answer is correct. Awesome. Okay. So now we're going to do a little... Oh, and also, before I go into this, I just want to pause. I know I'm going super fast. I'm only doing that because you can take all the time you need and read if you want to. But what's just to sort of touch on this, access all, we'll go into that in the access modifier section, so don't really worry about this. As a beginner concept, access all is usually what you're going to be putting. But that determines the access of this function or your variable. Access all is saying that anyone can access this. These are basically public in other languages, but again, we'll dive into this in a bit, so don't worry too much about that yet. So this is some basic math. It shows you incrementing a number, decrementing a number, or whatever. What we're gonna do is it wants to say in your createKitty function, add 1 to the existing total kitties variable. So the way we do that is say self.totalKitties equals self.totalKitties plus 1. Self is just referring to a variable in the above context. So if we just put kitties here or total kitties here, it doesn't know that it's talking to this variable. It would think it's like a local variable, like right here. So we have to say self in order to reference the variable above. So we will just say that instead. And if we submit, oh, it says it's wrong. Okay, so I wonder what did I do wrong here. Let's see. Let's ask for help. It's okay. So I'm actually okay. So I got this wrong. That's funny. So the reason is because in Cadence, let, and actually I should have read this note right here, my own note. The reason is because let is a constant. So in other languages, you might see constant, whatever. Basically, that means that the variable cannot change value once it's already been set to a value. So we have to change this to var, and once changed to var, now it can be changed. So if we submit the answer, it is correct. All right, moving on. So now we're on to structs. Structs are really cool. Again, very similar to other languages. Structs are basically a way to define your own type. So, we have strings, which is like text, or we have int, which is like a number. Struct is your own type that can contain other types. So in this case, you'll see this is a type that we created called person that has an age and a name in it, which are both strings. And so we can do that in our contract. Let's make a struct called kitty, which is our own type, access all struct kitty. And our kitty is going to have a name and a DNA. So access all let name, which is a string, and access all let DNA, which is a uint64. And again, in Cadence, we have to explicitly initialize these things. And actually, I think we're going to pass them in right here. So we're going to say name, which is a string, and a DNA, which is a uint64. And I'll show you why we're going to pass in these when it's getting created, but we'll say self.DNA equals DNA. So when we go to create a new kitty struct, we're going to have to pass in the name and DNA, which, you'll probably, it's probably obvious that we're going to be doing that in our createKitty function because we have those values right here. So we can submit that answer. Correct. Awesome. Okay, so now we are on to arrays. So arrays are, again, very similar to other languages, just a list of things. So we can go ahead and do that right here. So it says in our contract we want to create an array of kitty structs named kitties. So let's say access all let kitties, and it's going to be an array of kitty structs. So the way you do that in Cadence is you create square brackets and you type in kitty in the middle. So if you wanted to create an array of strings, it would be bracket, string, closing bracket. But in this case, we're going to do bracket, kitty, bracket like that. And remember, of course, in Cadence that we also have to initialize our value. So we're going to initialize this to an empty array. All right, correct. And I think we're going to dive into in this one. So in this one, I think we're going to be adding newly created kitties to this kitties array so that we can store kitties in there. All right, so let's go ahead and do that. So again, I'm going to skip most of this because you can read into this on your own time if you want. Also, you can probably hear my dogs barking. But let's put it to the test. So what we're gonna do is we're gonna make our I can't talk. Our create kitty function do something. So fill in the function body so it creates a new kitty and adds it to the kitties array. The name and DNA for the new kitty should come from the function arguments. Great. And it says to do it in 2 lines. First by creating the new kitty struct and then adding it to the array. So what we can do is say let new kitty, that's the name that it wants us to give it, equals the kitty struct. And we can open up parentheses, and it's expecting a name and DNA. So name is the name that we pass in, and DNA is the same thing. And then we can say self.kitties.append, because that is the how you add something to an array or to the back of an array in Cadence. And we're going to append the new kitty struct that we just created. Oh, and this is our answer is wrong. All right, so what did we do wrong here? So let's ask for help. Oh, and I forgot. It's because, actually, funny enough, in Cadence, this would actually work correctly. This would be totally fine. I think in order to pass this lesson, it's also cool to have people be really explicit about their type. In Cadence, you can specify the type of a variable by saying colon and then the type right before. So we know that new kitty is a kitty type. Of course, it's pretty obvious because we're literally creating a kitty object right here, but it's still good to specify it. And if we supply that, then we pass the lesson. But just remember that if you didn't put the type there, that Cadence would have actually worked the exact same way. So that's fine. Okay. So now access modifier. So this is where, this is like this access all stuff comes in. So this is actually, I would encourage you to read this on your own because it's an interesting discussion about public/private, especially if you're a Solidity developer. This stuff is really important. Access control is really unique in Cadence 1.0 and requires a more advanced course to get into. But when we're talking about public versus private, very simply, access all is public and access self is private. That's like the very straightforward, simple answer. So we're going to put it to the test. All it wants us to do is change create kitty to self. That way, no one will actually be able to, call this function. In fact, if this function was deployed, if this contract was deployed with this self here, this contract would be basically completely useless. It would never be interacted with because it can't. The only entryway into this contract is to call this function, and it's private, so no one can call it. But we're going to submit this answer just to pass this test, and then we'll see how we're going to actually make this contract come to life in a second here. Okay. So more on functions. So let's just, I actually just recorded a video about this. So view functions are, similar again to like languages like Solidity. A view function is basically something where it performs no state mutations inside of it. So it doesn't modify any state in the contract. That's pretty much all it is. So it's asking us to create a private function called generate random DNA. So let's do that. Let's say access all function generate random DNA. It will return a UN64. And then this function body should be empty, so we'll fill it in later. Okay, so I think we should just split an answer. Oh, something is wrong. Ask for help. And it's because, okay, so look at that. It says create a private function, and I made it access all. So we have to make it access self. All right, I love that I'm getting my own stuff wrong. Cool. So now we're going to talk a little bit about random. Again, really encourage you to read this on your own. But what's awesome about Cadence is that randomness is actually built into the language. This is awesome. Like in other smart contract languages like Solidity, you have to call oracles like OpenZeppelin, or I think it's Chainlink. I think it provides like an oracle to make random functions. That's always a problem, right? I mean, it works, but every time you have to rely on a third-party library, you're entrusting them, you're having to rely on external dependencies, right? The fact that Cadence has built-in randomness is actually a very, very strong feature. So we can show that here. So let's fill in the body of our generate random DNA function. The first line of code should create a random number called random num, which has a UN64 type. Okay, so we're going to say let random num, which has a UN64 type, equals, and we'll get to that in a second. And then the second line should return random num. So return random num. Okay, so how do we actually generate a random number? Well, we can go ahead and look at this because actually I kind of forget, so we kind of have to look at it. But let's see. So in order to do that, we have to say revertible random. Okay, and we want it to be a uint64. So revertible random with the parentheses, and all we do is supply the type in the middle here, which is uint64. Now that will pass, but really quickly, I want to show you that there's another way to generate a random with modulo built in. So if you want it to be a random number between like 0 and something, you can provide a modulo parameter to the revertible random function, specifying the type, and it'll return it in that type. But if we provided 5, for example, I think this would return a number between 0 and 5. So right, it also has an optional modulo parameter if provided the return integer has the same type of the modulo, and it's between 0 and modulo minus 1. So actually, this would return something between 0 and 4. So just interesting to know. But anyways, that is correct. So we'll keep moving. Okay. So we're going to actually be finishing our contract here. Wow, this has been so fast. And I don't expect you to go this fast on your own, but I'm just doing this because, obviously in the video format, I can do it a bit faster because I know all this already. But let's keep going. So step 1 is to create a public function named create random kitty. Okay, public function. So access all function create random kitty. It will take one parameter, name. So let's add name there. Okay. Also, sometimes this can be like dark. Just ignore that. We have to fix some of this stuff on this platform. But yeah, anyways, it is correct. So create random kitty. It will take one parameter named string. Okay. And the first line of the function should run the generate random DNA function on name and store it in a uint64 called randDNA. So let randDNA be a uint64 type that equals self.generate random DNA, right? And we're going to pass it because, generate random DNA doesn't require name. So actually, I should fix this wording because it's saying it requires name. It doesn't. So that should work. So just saying self.generate random DNA is great. We're going to store that in randDNA. And the second line should run the create kitty function and pass name and randDNA. So then we're going to say self.create kitty. Now look at this. Above, this has and actually I'm going to just decrease this for a second so you can kind of see. But create kitty is a private function. It has access self, but it can be called within the contract, right? So it can be called here. So self.createKitty, it's expecting a name and a DNA. So let's say the name is the name that we're passing here, and the DNA is going to be the randDNA that we generated above. So perfect. And we pass. All right, so I'm going to make sure to fix that description, by the way, because just going back to here, should run the function on name. It doesn't, so we don't pass name. I'm going to fix that. Okay, events. So really quickly on events, smart contracts are not good at telling other code when something has happened. Smart contracts are kind of self-contained. And so in order to know that an update's happened, you call into the contract, right, to view if state has been updated. Or you can do what's called listening to events. And so smart contracts can emit, it's called emitting an event, and then other code like your TypeScript or your whatever can listen for those events and then perform some action when that happens. So we can actually add an event to our contract. So it says declare an event called new kitty. So what we can do that by saying access all event new kitty, and it should pass kitty ID. So kitty ID, which is a uint64, and a name, which is a string, and a DNA, which is a uint64. Okay. And then modify the create random kitty function, so down here, to fire the new kitty event after adding the new kitty to our kitties array. So we can say emit new kitty, and we have to pass it those things. So the first one is the kitty ID. So it says you're going to need the kitty's ID. For this scenario, we can use total kitties as the ID. So the kitty ID is going to be self.totalKitties. That is the variable that we declared up here. Okay. Then we need the name, which is name, and then DNA, which is randDNA, right? And so we should be able to pass that. Perfect. Done. So this is where things get a little more complicated, and that's why we only have 3 lessons left. In Cadence, it's not just a smart contract, okay? So in Solidity, you just have a smart contract, right, which is a .sol file, and that's it. Now, if you want to run a transaction, you just run some like JavaScript function to call that function, and that's your transaction. Or a script just like runs, gasless sort of execution, right? On Cadence, it's actually quite different. So smart contracts are in their own .cdc file, their Cadence file. Transactions and scripts are also written in their own files. And so it's almost like transactions and scripts are the middlemen, where there's the person, right, like me, who wants to call into a contract. Then in the middle, there's a transaction and a script. And then on the other side, there's the contract. And so it's sort of like this line where I want to, mutate something in the contract. I call a transaction, which calls into the contract. Or if I want to read data from the contract, I execute a script, which reads into the contract, okay? So that's kind of how that works. So we have our contract right here, but we're going to be writing a transaction file to actually call into our contract. So this is sort of like the base, transaction layout. I'll just write it here. So transaction prepare signer has a reference to account. I'll explain this in a second. So a transaction has two stages in it. The prepare phase, where you have access to the signer's account. So this is like a dangerous piece of code here. And then execute, which is where normal execution happens. The reason that you have this prepare statement, and again, this is more of like an advanced concept that isn't in this beginner course, but in the prepare stage is where you have access to a user's account. This is extremely different from languages like Solidity or other smart contract languages, because this is like a move-based language where we have resources and resources get stored in our account. Again, that's more like more chapters coming. Just wait for those. So for this one, we're just going to stick in the execute phase, which is where we can execute functions in our contract. So create a transaction, right? And then that calls the create random kitty. So in order to actually call that function, we have to import, and I'm actually curious how we do this. So import, it's called kitty creator, like that. And we can execute it by saying kitty creator dot, and we're going to be calling the create random kitty function, which accepts a name, which is a string. And I'll show you this in a second. And also that's it. So it just accepts a name. And actually we can see that here. Create random kitty just accepts a name. Now, in order to pass in a name, we have to add a name argument to our transaction. So, theoretically, when someone is calling this transaction in JavaScript or something, they're going to call a function that passes in a name here, and then that'll get passed to the create random kitty function here. So we can submit our answer, and we're correct. Now, scripts, same concept, except now we're reading data from the contract instead of changing it. And scripts have a different format. So we have to first obviously import kitty creator, which is our contract. Then we can say access all function main. And this is the normal, format of a script. And if you want to return something, it's the same as other functions where you put colon and then the type. So we're going to return an int here. And what we're going to do is we're going to create a script that accepts a kitty index. Okay, so it accepts a kitty index, which is an integer, and returns the kitty at that. I'm sorry. So we're not returning an int. We're returning a kitty creator dot kitty. Okay, so we're going to return kitty creator dot kitties, which is the array here. Okay, and we're going to index into it at kitty index, just like that. And we're going to return a kitty struct. Now, because we're not actually in the contract that defined kitty, we can't just say return kitty here, because that type is not in this scope. We have to tell it it's the kitty creator dot kitty struct, because as you can imagine, people can define any kitty struct they want in their own contract. So we're specifying it's this one. So if we run this, we should get that we are correct. And then this is it. That's pretty much it. I mean, now you can kind of see that, we just made our transaction script and contract. And this actually shows you using FCL, which is the library that allows you to interact with the Flow blockchain in TypeScript or JavaScript. This actually shows you how we would use that Cadence code to actually do what we're doing on the right here. So again, you could play around with this on your own, and there's so many tutorials on FCL on Emerald Academy, which is academy.ecdao.org. Again, a whole resource of FCL content. But this kind of shows you that, okay, if we put in our contract address here, and then we have like a little input here, right? This is our name input, and if we type something into here, this is actually going to call the transaction that we defined, right? Which is really cool. So it's going to call our transaction. And then what that does is, remember, that emits an event, because that transaction is calling create random kitty, which emits an event in the contract. And so here we're listening for those events and then calling generate kitty. So every single time someone types something into the button, input here, it's running a transaction. That transaction is emitting an event. This is reading the event, calling generate kitty, and then it's actually generating this image on the right side randomly, which is displaying a random kitty, which is super cool, using the random DNA that we created on chain. So there's like multiple levels of randomness here. But anyways, super cool. And that's pretty much it. Yeah. Now, of course, like on mainnet, testnet, every time you type a letter in here, it's not going to run a transaction that fast. But this is all just sort of simulated, but still cool nonetheless. So that's it. We finished our courses, and we're done. And you can see now I've completed this mission. So I hope this was helpful for all of you. We even see this now, which is super cool. But I hope this was helpful for all of you. Again, wait for more chapters where we go more in depth on some more complicated stuff like resources, account storage, entitlements, capability controllers, blah, blah, blah. But that's it. Hope you enjoyed and have a great rest of your day. Bye.